It is very similar into what we've been doing up until this point. When we are adding and trying to solve for that variable, or it could be subtracting too, I guess, we need to always start by first looking for your common denominator. And remember, if you have any binomials in your denominator, those have to automatically be included. So in the case of our first problem here, x plus 1 would be automatically included. We then need to look at your monomials, which are these two right here. And with our monomials, we need to figure out what is our least common multiple. So if we look at the numbers in front, 3 over x, there's a 1 in front of that x. 5 over 2x, there's a 2 in front of the x. So the least common multiple of 1 and 2 is 2. So we would put a 2. And then the most amount of variables that we can have would just be a single x because they both have a single x. And then from here, our next piece is we need to make sure that each term has our common denominator. So 2 over x plus 1, if we're trying to make that look like our common denominator, it's missing the 2x. So we're going to say 2 times 2x to the top and times 2x to the bottom. Now our denominator looks like our common denominator. For 3 over x, it's missing the 2 and the x plus 1. So we'd have 3 times 2 times x plus 1 all over 2 times x plus 1. And now our denominators look the same. So we are just adding in the pieces that are missing. And for our last term, 5 over 2x, it's missing x plus 1. So we need to multiply the numerator and denominator by x plus 1. And now that all of your denominators are the exact same, you can go ahead and cross them out. And we can rewrite our numerators. 2 times 2x is 4x. Plus 3 times 2 is 6 times x plus 1. Equals, we can distribute our 5 in to give us 5x plus 5. And then simplifying even further, we get 4x plus 6 times x is 6x. 6 times 1 is 6. Equals 5x plus 5. And that's 10x plus 6 equals 5x plus 5. And if I subtract 5x and subtract 5x, we get 5x plus 6 equals 5. Minus 6 minus 6. 5x equals negative 1, divide by 5, divide by 5, and we get x equals negative 1/5. And then from here, if we were to check our answer, you would substitute in negative 1/5 in for wherever you see an x. So when we go to check our answer, actually, I don't even know if that's a part of our stuff today. Yep, check your solution. So when we go to check our solution, we're going to rewrite our equation, and wherever there's an x, we're going to put a negative 1/5. So that's going to give us 2 over negative 1/5 plus 1 plus 3 over negative 1/5 equals 5 over 2 times negative 1/5. And from here, when you go to simplify, 2 over negative 1/5 plus 1, that's the same as 2 over negative 1/5 plus 1 is the same as 4/5. Plus, remember, we could always rewrite this as plus 3 times the reciprocal. So 5 over negative 1 equals 5 over negative 2/5, which is the same as 2 times 5 over 4 plus 3 times negative 5 equals 5 times 5 over negative 2. So all we're doing is we're multiplying by the reciprocal. And 2 times 5 is 10. 10 divided by 4 is going to give us 2.5. Plus 3 times negative 5 is negative 15. So we can actually write that as a minus 15. And then 5 times 5 is 25 divided by negative 2 is going to give you negative 12.5. And if we look, 2 minus 15 is negative 12.5. So that would make them equivalent, giving us a solution. So you're just solving for x and substituting in. Do not be afraid of fractions. They will always pop up for us. For our next problem, when we're looking for our common denominator, we have a t plus 3, we have a t, and we just have a single number. Remember that single number is always divided by 1. So in our common denominator, you have t plus 3 for sure, because that's your binomial. And then our only binomial we're actually worrying about is t. So we just need each denominator to look like t times t plus 3. So in order to make our first term there, 8 over t plus 3, look like our common denominator, you need to multiply the top and bottom by t. And the second one, 1 over t, is missing your t plus 3, so it's going to be 1 times t plus 3 all over t times t plus 3. And that's going to be equal to or not equal to. And you're going to add that to our 1 is actually missing everything. So you need to multiply by t times t plus 3 to the numerator and the denominator. And now that they are all the same, you can cancel them out. 1, 2, 3. And we can rewrite our numerators. 8 times t is 8t equals 1 times t plus 3 is just t plus 3 plus t times t is t squared. T times 3 is 3t. And combining like terms, 8t is equal to t squared plus 4t plus 3. We subtract 8t to both sides. We get 0 equals t squared minus 4t plus 3. And with this now we have a trinomial. To solve for our variables, you need to factor your trinomial into two binomials. And with this, since a is 1, we can put t and t in the front of our parentheses. Multiplication pair of 3 to give you negative 4 is minus 3 minus 1. So then we would say t minus 3 equals 0. So we're just rewriting it. And solve for t to get t equals 3. And we would say t minus 1 equals 0. So we did this once already when we were finding our zeros and graphing our quadratic functions. And then when we go to check our answer, we actually have to check. We actually have to check both of them. So when t is equal to 3, when t is equal to 3, you substitute it in. So you'd have 8 over 3 plus 3 equals 1 over 3 plus 1. Well, 8 over 3 plus 3 is 8 over 6. And that's equal to 1/3 plus 1 is actually 4/3. And those are equivalent, so we have a solution. When you substitute in t equals 1, you get 8 over 1 plus 3. Equals 1 over 1 plus 1, or 8 over 4 equals 1 plus 1, or 2 equals 2, which means that is also a solution. And for our last one, notice that we have no binomials. Your common denominator then is only based off of your monomials, which our monomials are x squared, x, and remember that would just be 1. And the most amount of variables they share is x squared, and that is it. So for your first term, we don't have to do anything to get our common denominator, so that stays the same. And that's equal to our second term is missing an x. So we say 1 times x over x times x. Plus, our last term is missing everything, so it's going to be 1 times x squared over x squared. And with this, these are all the same denominator now, so you can cancel them out. And then we would rewrite this as 12 equals, and this is just our numerators, x plus x squared. If we subtract 12 to both sides, you get 0 equals x squared plus x minus 12. And then once again, we need to factor and solve, so 0 is equal to, since a is 1, we can put our x, or that variable, in the front. Multiplication pair of 12, you're going to have a plus 4 minus 3, and that'll give you your 1. So then you just rewrite both. X plus 4 equals 0. Solving for x, you subtract 4. X equals negative 4. And rewrite your x minus 3. Set it equal to 0. Plus 3 plus 3. X is going to be equal to 3. And then for both of these, you just need to check your solution. So when we check our solution, for x equals negative 4, you would say, okay, we have 12 over negative 4 squared equals 1 over negative 4 plus 1. Negative 4 squared is 16, so we get 12 over 16 equals negative 1/4 plus 1 is 3/4. And since those are equivalent fractions, that would be a solution. For x equals 3, when you substitute it in, you get 12 over 3 squared equals 1/3 plus 1, which is the same as 12 over 9 equals 4 over 3. And those are also equivalent, giving you a solution. All right, that is all we have for our notes. So you're just solving, checking your answer. Notice the difference today is when you go to simplify your numerators, you might get a trinomial. And if that happens, that's fine. You just factor it and solve it like you normally would. Have a good day, guys. We will